Good morning, everyone. Today I'm presenting my complete report-driven revenue management system. This system is a modular, production-style RMS prototype designed to ingest messy PMS reports, normalize and validate the data, forecast demand, simulate pricing, and generate explainable revenue recommendations. The goal of this project was not simply to calculate hotel KPIs, but to build a structured, extensible revenue engine that mirrors how a real-world RMS would function, while retaining realistic within a 4-week academic scope. Right now, I'll walk you through the system architecture, data ingested and validation, forecasting and analytics, pricing simulation logic, decision support, outputs, and overall system impact. So, what does the system do? This system runs in 2 modes. First is a Streamlit UI using Streamlit Run app.py or a simple launcher file. Second, a CLI mode using Python main for automation or batch processing, and ingest historical PMS reports, optional future on the book reports, events, event calendar, and budget files. It accepts both CSV files and Excel formats, including .csv, XLSX, and XLS, with parsing fallbacks in case the file structure is inconsistent. This dual interface design makes it usable for both analysts and automation workflows. Data preparation and validation. One of the most important engineering components is the data normalization layer. Hotels export reports with inconsistent column names. For example, ADR, average daily rate with underscores, room revenue. The system automatically maps every PMS column name into a canonical schema. Required fields include stay date, rooms available, rooms sold, room revenue. Optional fields include pricing and contextual inputs. If the system can't confidently map a column, it falls back to manual interactive mapping. This mirrors production ETL systems where automation is prioritized but human override is supported. After mapping, the validation engine runs. It checks validate parsing, non-negative numbers, business rule compliance, overbooking logic, missing required fields. Validation diagnostics are written to output files for transparency. The system can run in interactive mode or fail fast mode for automation pipelines. This ensures reliability and reproducibility. Once validated, the system computes core hotel KPIs, occupancy, ADR, RevPAR, processes daily, weekly, and monthly aggregations. From there, the forecasting engine activates. The base forecast uses seasonally driven baseline derived from historical patterns. Event adjusted demand is layered on top. If event intensity is high, demand expectations are adjusted accordingly. The system also includes enhanced machine learning forecast using random forest linear regression fallback. If machine learning is enabled, the system performs holdout backtesting to measure forecast quality. It computes MAPE, MAE, RMSE directional accuracy. This allows the system to quantify forecast confidence instead of relying purely on heuristics. That combination of statistical baseline plus machine learning fallback improves robustness. Pricing simulation engine. So, just to go over kind of what we've done, we have a pricing system, right? And so this code here just goes over the logic for how we decide what the forecast for prices is. And it looks for everything that it needs to run. Quite a lot here. And then it returns all of this. Pricing engine simulates candidate rates about the current rate. It uses elasticity assumptions to estimate expected revenue per candidate For each state aid, it evaluates which simulated rate produces the highest expected revenue. However, pricing guardrails are applied. Floor and ceiling rate constraints, maximum daily change limits, weekend premium bands, non-negative enforcement. It also incorporates such signals such as pace versus same time last year, event impact, budget pressure signals. This prevents unrealistic recommendations and mirrors real revenue management constraints. Each recommendation includes confidence score, constraint notes, and rational signals. This ensures recommendations are explainable. Explainability is critical for adoption in hospitality environments. After simulation, the system produces decision support artifacts. It generates ranked action lists including top raise opportunities, rescue dates where demand is weak, monitor dates requiring observation. Each date receives a priority score. It also outputs comparison artifacts such as baseline versus new pricing policy, projected revenue uplift. The UI provides KPI cards, interactive charts, forecast versus actual plots, rate trend charts, uplift visualization, pre-file downloads, one-click zip export. All artifacts are exportable as table and CSV files. This makes the system usable beyond the application itself. The limitations of the system. So far, the system does not include live PMS integration, full production database backend, deep neural forecasting. It's still an offline analytical engine. However, the architecture supports those future expansions. In conclusion, this project demonstrates that structured schema normalization dramatically improves data reliability. Layered validation prevents flawed revenue decisions. Seasonality plus machine learning forecast enhances predictive accuracy. Guardrail elasticity simulation creates explainable pricing recommendations, and modular architecture allows the system to scale into a full AI-driven RMS. This is not simply a KPI calculator. It's a structured, extensible revenue decision engine. So now let's go ahead and just give it a quick test run here. Let me go ahead and open it. Please mind my files. We have a launcher. It's not going to work now because I need it to. No, it really isn't going to work. Alright. So you have the pricing configuration still. We want to set our rooms to 99 because that's how many our report we're going to use has. Historical, we'll go ahead and import the data. So I went ahead and downloaded the entire Q1. I called it Q2. It's Q. Or what? No. Yeah, it is Q2. So we want Q2 for historical. And then we're going to want future on the book. So that's what I have here. And so then we're going to go ahead and make sure the stay date's good. It's going to be 3, and it'll be, I believe it's 8 here. And we can check that here, right? So those are columns. I also have optional pricing mapping. We want to have ADR, which is going to be 10. We'll just do the same thing for here because it needs to do it. And we're going to do it as 10. Alright, we're going to hit run pricing simulation. Alright, so I don't have a budget in place yet. The budget I had was working. The only issue is that the budget doesn't. These are real numbers I got from my hotel, so I'm trying to get the actual budget still. But we're just waiting on that. But so it shows what's on the book. It shows base demand. Base demand is how many, what percent occupancy we're looking at, but we're over base demand. So when the forecast, looks at here, it kind of goes where we should be. And then it gives a good recommendation. So typically what I've noticed is if the on the books is higher than the base demand, your forecasted room sold is going to stay around there. And just from what I've run recently, this program has been predicting accurately what the hotel's actually turning out with no input. So these graphs or these charts here, well, yeah, there you go. So I don't have a mouse, but they are interactable. You can click on exactly what you want to see. April for this year, the data is present. It's just it's that low. There really is nothing on the books for April right now, so that's why you're not seeing any that big drop there. It's not that it's not reading it. It's that April, I think, literally has, yeah, nothing really on the books. And then this shows the year over year comparison. So you can go ahead and, well, yeah, you can go ahead and look. So you have the occupancy. Same time last year is the blue. And so we want to see, like, oh, look, okay. Like, those are your days. And then these are the downloads. And that is the end of the little demo here. You have the forecast versus actual room solds. This one here, I think, is what is really a big one, you know? So, yeah. Uplift. Originally, I was going to make it 1%, but after kind of, I think this looks more helpful for at a glance, property manager. So that's what we're doing there. But other than that, thank you for the time today. Have a good rest of your day.